So this is some questions that I've been asked to go through from 325 from 2011 papers by a couple of you, so I've just uploaded this so you can have a look at it and see what how to go through these questions. So the first one is 4b part 2. There was actually a mistake in the question paper. It doesn't affect the workings on the chemistry, but just for completeness, that should have been the positive electrode there, and that one should have been the negative electrode. So we're trying to come up with the second half equation, which we'll add together with this half equation to make the complete combustion of methanol. So combustion of the methanol won't cause you too many problems in balancing that one. So we take the methanol and we know we've got oxygen, and that'll form carbon dioxide and water. And then balancing out, we've got 4 hydrogens this side, 2 hydrogens that side, so we need 2 waters, and then that gives us 4 oxygens on that side, 3 on that side, so we'll take 1.5 of them. So overall, that's our final equation, that's the one we want to produce. So that's CH3COH plus 1.5 oxygens, and CO2 and some water. So that's the overall equation we want. Up here we can see that we've got the positive electrode, we've got our oxygen turning and hydrogen ions turning into water. If we look at the balancing, so 1 oxygen here and 4 hydrogen ions making 2 waters. If we balance this half equation with our final equation that we're trying to get to, we've got 1.5 oxygens here, so we're going to need 1.5 of all of this, so 1.5 of that. 1.5 times 4 is obviously 6. And then 6 there, and then that will give us 3 waters. So if we put that up there, O2, and then 6 hydrogens and 6 electrons will give us 3 waters. So that's the reaction at the positive electrode. At the negative electrode, we obviously have the methanol reacting, and we're producing lots of water here, which we've got in the final equation. We haven't got any carbon dioxide, so it stands to reason that our methanol carbons are going to be ending up in the carbon dioxide. We've got 6 hydrogens on this side, we've got no hydrogens on this side at the moment, so these must go in here to balance those ones out, and we've got 6 electrons here, so those 6 electrons must go in there to balance it out. And then the final part, on this balancing, we ended up with 3 waters. In the final equation we've only got 2 waters, so there must be a water on that side to balance that out. And then if we run through the cancelling out just to check that, we've got 6 hydrogens there, 6 hydrogen ions there, 6 electrons there, 6 electrons there, and then 1 water there and 3 waters there, so that one cancels, and that gives us 2 waters. We end up with hopefully the right equation, so methanol, methanol, 1.5 oxygens makes 2 waters and 1 carbon dioxide, so that all balances. So this then here is the half equation for the reaction at the negative electrode. The actual reactions that occur in these fuel cells are quite complex, and so we're just working on deducing what's going on, and we don't need to worry about the detailed chemistry too much at A level. So that's how you work through that question.